Well, hello. We're going to now factor these quadratics where a is not 1. So we're going to factor all sorts of quadratics now. I like the area model for factoring, so I'm going to go through how to do that. Let's jump into it. Here we go. So if you're going to factor something like 5x squared plus 15x plus 10, 5x squared plus 15x. Oh boy, I didn't space that very well. Let me enlarge this here. Woo! All right, well, should we go full screen? It doesn't. So if I'm going to factor this thing right here, before you start drawing boxes and all that, what you want to do is see if there is a GCF that you can pull out of all three of these. So is there a number that you can factor out of all three of these terms? Yes. Yes, there is, and it's 5. So the first thing you want to do is factor out 5. So you can undistribute the 5, and you end up getting that. Okay, so if you have any questions on where that comes from, make sure to let me know. And then what you're going to do is factor the x squared plus 3x plus 2, just like we did in yesterday's assignment. So then, I wish I had a larger whiteboard or a second one. I don't. So then you would do a box. I would do a box. You can unfoil or do it however you want, but I like the area model. So, oh boy, that's not the nicest. But anyway, so I have to figure out what do I have to multiply to get 2 that adds up to 3, and that'll be 1 and 2. So there we go. I fill out the rest of the box. It looks like that. So then my factors are, the final factored form, don't forget about the 5 out front. The 5 is still one of the factors. So it's going to be 5 times x plus 1 times x plus 2. So that down there is a factored form for that. Okay. This is an example that you might want to jot down. And then I'll just click through the slides also. So I'll leave that on there. And then click through the slides. Make myself smaller. Whee! Okay, here we go. So yeah, don't forget to do the GCF first. So pull out any common factors first, and then factor the rest of it. Oh, and they just jump straight to that, from that to that, because you're an expert at it now after you did 7.5. All right, so there we go. So don't forget when you're factoring, pull out GCFs first. Don't forget the GCF in your final factored form. That's some good alliteration right there. Let's jump into another one. Here we go. Okay, so first question for you for A there is what is the GCF for 4, 13, and 3? Yeah, that GCF is 1. So there's no actual GCF to pull out. So this one we're just going to have to factor, like difficult method with the area model. I'm going to make this bigger again. Again, it'd be nice if that would go full screen. It doesn't, but that's okay. It doesn't even stay in the middle of the screen. What? Okay, so the 4x squared goes here, and then the 3 is going to go down here. Now, here's the thing. The 13x doesn't come from just the two terms that we're going to use added together. That's the tough thing about this. So we don't even know what these two terms are here and here. Before, yesterday, it was just x and x, no problem. This could be 2x, 2x. It could be x and 4x. And depending on which one we make the 4x, that'll change the number that's in the other boxes. So this is slightly messier. But I don't know if you remember, I mentioned it in class yesterday. When you multiply the diagonals here, when you multiply those two, it's got to be the same as when you multiply those two. So the numbers that are going to go here and here are going to have to be 12x squared when we multiply them. Okay. So anyway, the nice thing about the 3 is there's only one way to get the 3. So this has to be a 1 and a 3. All right. Also, I didn't mention this. A lot of you might just want to do the Ed puzzle in the background. No, you got to focus on this one. This is like a murder mystery TV show. Like, you need to be in every part of this Ed puzzle. Can't do the background on this one, or you're not going to understand anything. So the 3 and the 1 have to be there. It doesn't matter if you put which way you have it. But the trick is now we got to figure out what goes here and here. Now it could be 2x and 2x. Let's try it. Okay, so if that's the case, that'll give us the 4x squared. We'll have 6x there, and we'll have 2x here. Okay, those add up to 8x, though. And notice up there on the screen, it's supposed to add up to 13x. Oh, that doesn't work. Okay, so it's not 2x and 2x. Okay. So we just got to try other numbers for now. You'll learn some strategies as you do these. But yeah, it's not going to be 2x and 2x. So it's got to be 4x and x. The trick is, where does the 4x go and where does the x go? Like, which one's which? Okay, if I put the 4x here and the 1x here, then that'll make this 12x here, because that's going to be 4x times 3. And then in the bottom blank corner there, that's going to be x. And these ones do add up to 13x. Yay, we found it. Okay, so the factored form is going to be x plus 3 times 4x plus 1. I'll let you jot that in your notes if you want. And then we'll go through big ideas how they do it. I'll make this smaller again. Okay. So they make a table. This is another great way to do it. Just kind of organize a table like this. So this is a good way of doing the area model, but like in an organized way. And it allows you to show all the possibilities. So if you don't like this area model, this is another way to do it using a table. So I would suggest jotting down one of those methods. Okay, and then you find out, oh yeah, this is the one that works right here. Okay, so there we go. That is factored now. A great thing to add to your notes using the table form, if the area model doesn't work for you. All right, so now what I want you to do is try B on your own, okay? Either with the area model or this lovely factor table thing they made here. So try to factor 3x squared minus 7x plus 2. Good luck. All right, let's see how you did. There's no GCF to pull out. There's no common factor between 3, 7, and 2 except for 1. So they did factors of 3 and factors of 2 because those are the two products you have to have for the first and last term. And because this middle term is negative, both of these have to be negative factors for the 2. Because they have to multiply to give you positive 2, but add up to be a negative number. So then you just try them out and see which one fits. And you'll see, oh, when you try, and they use the little check marks. When you try the second one, this combination, it works out great. Therefore, the factors are x minus 2 and 3x minus 1. Okay, another great example to add to your notes. Let's practice some more. Okay, give this one a shot. Good luck. I'm going to show you how to do this with the area model. Okay, so they're going to do the table, which I'll leave on the screen in case you want to copy that. And then I'm going to quickly do this with the area model. Well, try to do it quickly. Here we go. Okay. All right, so we got 2x squared. That's going to be upper corner here. And then we got negative 7 is going to be the bottom corner there. Okay. Whee! Now, the nice thing about the negative 7, oops, there we go, is there's only one way to get it. Just you can have, well, 2 ways to get it. So 1 and negative 7 or negative 1 and positive 7. Okay, here's the thing, though. I know that I'm going to have a middle term that's negative 5. So I know the 7 is the one that has to be a negative because my middle term is going to end up being more negative than the other. And then the only way to get 2x squared is to do 2x times x. Now I just got to figure out which one has to be the 2. And just from practice, I know it's got to go here and here, because if I had the 2 in the other spot, it would give me 14x, and that's too much. I don't want that. So that gives me negative 7x here, 2x here. Those add up to the negative 5x I need, and everything else is great. Therefore, the factors are x plus 1 times 2x minus 7. So this is the area model way of doing the same problem. All right, it's more like solving a puzzle, though, whereas the table is a nice organized way to check all possible solutions. Okay, so now that you've taken great notes on that, let's jump into a third example. Actually, no, this one's the same as the other ones. I want to keep this video shorter. So this one's the same as the other ones. You can either do area model or make a nice organized table. I'm just going to click through and show you the table in case you want to copy it down. It's a big one. There you go. And then you go through, and because there's a lot of ways to get these possible factors. Oh, and that's the trick. When this is a negative number, one of the numbers has to be negative, the other one has to be positive, which means you have a lot of combinations to check. So, and then you find out which one works, and there it is. Okay. And in this case, they had a negative in front just to make it easier. You normally don't want your leading coefficient for these monomials to be a negative. It's not wrong to have negative 2x plus 1, though, times 2x plus 5. Okay, and now we have this type of problem. I wanted to go over this because it's a story problem that you got to solve this thing here. And again, just to keep it shorter, I'm just going to talk through it and then not ask a ton of questions. So the length of the rectangular game reserve is 1 mile longer than twice the width. I do want you, though, to see if you can come up with, if the length is x, how would you write? Oh, no, wait, the length of the game reserve is 1 mile. Sorry, if the width is x, how would you write the length? Okay, so if you said 2x plus 1, you're right. They're using w instead of x, but you know, whatever. Okay, and then the area is 55. Therefore, when you multiply w, which is the width, times 2w plus 1, which is the length, you get this. Okay, and you can't solve this the normal way that you would solve an equation because you have the x or the w squared. So what you want to do is subtract 55 on each side and end up with this, and then we got to factor it. All right, so when you factor this, actually this one I will make you try. So try to factor 2w squared plus w minus 55 on your paper. Good luck. All right, when you factor it, you end up getting, oh wow, they did this using the table. Very long, but it works. You'll find out that the factors are w minus 5 times 2w plus 11. Okay, and then those equal 0. So then you would solve for either of those. So w is either 5 or it's negative 11 halves, but you can't have a width that's a negative number, so that doesn't make sense. Therefore, the width is 5. All right, so that is a type of word problem that you might see where you have to do a little solving. Let me again go back to the beginning of that because that's the important part. I could have done that a little faster. The important part is realizing if you end up with something like this, you want to get equals 0 on one side and then factor to solve it. All right, that was a lot. Feel free to rewatch this video. Ask me questions if you have a lot of questions on this, and I will see you in class. All right.